Section 4.5 is solving systems of inequalities. So we've talked about solving systems of equations, where we're looking for the intersection of two lines, which is usually just a single point. Now we're looking for the intersection of two inequalities on a graph, and that's going to be the overlapping shaded area. So first, let's recall a few things we know about linear inequalities. So from Unit 3, when we graph a linear inequality, we graph it as a half plane. So we have either a dashed or solid line. We also have shading above or below. So just to make sure we remember all the steps, we have 4 things to worry about. The first thing, when we're graphing our line, is we need to know what the slope is. Okay, so this is m equals our rise over our run. The next thing we need when we're graphing a line, we also need our y-intercept, or our b value. And this is where the graph starts. So knowing those, we can plot our line, except because it's an inequality, we need to know, is our line solid or is it dashed? And based on our inequality signs, a solid line would be less than or equal to or greater than or equal to. Because of that extra line, we have to connect our points. Dashed line would be less than or greater than. And then the fourth and final thing is the shading. Do we shade above or below? So shading, it's either above or below. And above is greater than or equal to. Below would be if we have less than or equal to. So that's all review. Now, that applies for a single inequality, but it also applies for a system of inequalities. So our general steps here to graphing and solving a system of inequalities, to start out, what we'll do is, step 1, make sure both inequalities are in y equals mx plus b form. So we want to make sure that they're in our slope-intercept form because that's the easiest way to graph them. Step 2, graph the first inequality. Step 3, graph the second inequality. Okay, and for these two steps, 2 and 3, we want to make sure to remember numbers 1 through 4 above. We want to make sure that we get all of those pieces of 1 through 4 correct. And then after that, what we're going to have is 2 different inequalities graphed on one plane. The overlapping region of shaded areas is our solution. So we'll look at a couple examples of that. Here's our first example. So solve this system. We have 2 inequalities, a system of inequalities. So for line 1, I'm going to do that in red. My y-intercept is -5, so I start on the y-axis at -5. And my slope is 2. I can write it as 2 over 1. So I'm going to go up 2 over 1. So let's get a bunch of points on our graph, up 2 over 1, up 2 over 1, etc. Okay, and from that point we can also go down 2 and back 1. Less than means a dotted line, and less than means shade below. So I'm going to have a dotted line if I connect this. Like so. And I'm going to shade below. And for my shading, I'm going to just use a highlighter because I think it makes a little more sense here. It's easier to see. I'm going to shade everything down in this area here. Okay. So that's for my red line. Now I'm going to do the same process for my other line, my other inequality, I should say. I'll do this one in green. So I start at a y-intercept of 6, so I'm going to go up 6 on the y-axis. And my slope is -1/2. So negative slopes are always going down from left to right. So I'm going to go down 1 and over to the right 2. Down 1 to the right 2. Down 1 to the right 2. Greater than or equal to means solid. Greater than or equal to also means shade above. So I'm going to draw a solid line through these points that I just found. And then I'm going to use my highlighter to highlight above this line. Okay. So the overlapping region right here, you can see where those two colors of green and the purple, where those overlap, that's your solution. So the overlapping region is a solution. So normally our solution when we had a system of equations, our solution was a single point. Here we have an infinite number of points, all that are found within that dark shaded region where they overlap. So we're going to do one more example together. Our next example, we have two inequalities, but they are not in y equals mx plus b form. So looking again at those steps, step 1 was make sure both inequalities are in mx plus b form. So let's go ahead and do that. If I rearrange this first equation, I would have to add 3x to move it the other side. So that's going to give me y is greater than 3x minus 4. In my second inequality, I have 2y, so I need to divide everything by 2 in order to get y alone. So I'm going to divide everything by 2, and that gives me y less than or equal to -8 divided by 2 gives me a -4 times x, and 6 divided by 2 will give me a +3. So -4x plus 3. So same process, we're in mx plus b form. I'll do my top one in red. I start at -4, and my slope is +3. So I go up 3 over 1, up 3 over 1, etc. And down 3 and back 1 from that point. Because it's strictly greater than means a dotted line. Greater than means above. So we'll do a dotted line. And when I do my shading this time, it's going to be above the line, so on this kind of left-hand side. And let's make our thickness bigger so it doesn't take forever. Okay, so this whole region over here is going to be shaded purple. So we'll get that whole area shaded. Okay, that's our first line. Our next line we're going to do in green. Our y-intercept is +3. So on the y-axis I go to +3, and my slope is -4. So I'm going to go down 4 and over to the right 1. So we have a negative slope. And down 4 again, over to the right 1. I can also go back to my y-intercept and go up 4 to the left 1. And our green line is going to have be solid because it's less than or equal to. So that means it's a solid line, and less than or equal to means below, because it's less than. So we're going to shade below this line. So solid, connect those points with a solid line. And, oops. Sorry. Our Final step will be shading it. So I'll get my green shader out. And I'm going to shade below this line. So that whole region over here on this left side is overlapping. Okay, you can see that the green and the purple regions, kind of right in the middle here, those sections were solutions to one of our inequalities, but because they're not overlapping, they're not solutions to both of our inequalities. So the only solution is that dark region right there. So all of those points in there. Okay? All right, so there, as always, there's one problem for you to try. Looks like these ones are already in mx plus b form, so you need to graph the two inequalities and see where their regions overlap. And I recommend using different colors. I think it helps to tell what is your final solution. So go ahead and give that one a shot.